Is it true that you need an expensive Mopa fiber laser to create stunningly vivid colors on stainless steel? Not at all, and I'll show you how to do it if you stick around. First of all, if you're new, then welcome to the channel, and if you're already subscribed, then welcome back. The only paracord I'll show you in this video is the inventory hanging right behind me. I drew this butterfly in freehand, then I took a picture of it, sent it to the computer, made it black and white, reinforced the lines in GIMP, which is a free graphics and image manipulation software, and this is what we're going to use. First up, I import the drawing into Lightburn, right-click it, and trace the image. Then I mark it, press the button to ungroup it, so I can remove any unwanted parts, and then I scale it down to fit on the dog tag. The blue tool lines on the screen correspond to the jig plate that I have burned out on the laser to achieve near perfect placements every time I run the laser. The jig plate also allows me to make multiple projects at once, or even do small-scale mass production runs. I use the lasers to achieve different results, and each color is going to be a different layer. I want my lines to be black, so I set that layer to line and 900 mm per minute and 90% power. So far so good. The fields I want to make blue, I mark with the blue layer and so on, just for the sake of my sanity and to avoid confusion. The colors in the program are only there to avoid confusion. The coloring of the metal is achieved by a process called annealing. When the metal is heated, oxygen is diffused down below the surface of the metal. The metal then begins to oxidize internally. Once it has cooled off, you're able to see a change in the color of the metal. It's actually quite a fascinating process, and I do recommend Googling it for yourself to learn more. Anyway, what you need to know to achieve the colors is that certain temperatures make certain colors, and the intensity of your laser heats the steel to a certain temperature. While filming this video, it is winter and my garage is only 2 degrees Celsius, and in the summer I'll achieve different colors with the same laser intensity. This is why I make these small color tests at different temperatures, so I have a solid starting point by looking at the thermometer, thus avoid guessing and shooting in the blind. A good friend just recently pointed out that I might be wanting to get a hygrometer so I can measure the air humidity, as the evaporation might influence the temperature as well as the room temperature does, since evaporation cools down the materials. So I guess I'll spend the next year by being very thorough with taking good notes. Anyway, I have set my variations to 900 mm per minute, selected fill on my color layers, and set the line interval to 0.030 mm, and chosen power/intensity from 41% for the blue one, and so on. I have also copied the whole figure and converted it to black lines and pasted them exactly over so I get nice lines on my finished results. Please note that I normally close the enclosure for safety. Losing an eye for a piece of colored steel would be a horrible trade-off, but losing an eye to make a video for you guys is definitely worth it. I'm joking, of course, I have laser protection goggles as well. For the sake of brevity, let's just cut to the finished result. I don't want to bore you with watching the laser run for 16 minutes more, and I've shown you the how already. If you're wondering how to achieve vibrant colors on stainless steel, I hope this video has helped you out. Please let me know in the comments if you found it useful and you want me to share more lasering tips, tricks and experience, like how I make my jig plates, or even if you want some tips on how to engrave on slate plates. Oh, and also thank you for watching, and if you feel like I've earned it, likes, comments and subscriptions helps motivate me to make more videos for you guys.